a student was asked to add about 18 gram of artificial sweetener to 100 gram of water. After dissolving the sweetener, it was observed that the vapor pressure of the water was lowered by 0.300 millimeter of mercury from 17 millimeter of mercury. Can you identify the sweetener used? Is it saccharin or sucralose? Well, that is possible. You can identify from the sweetener based on the molecular weight. How is it possible to calculate the molecular weight of a solute based on the given data? To solve this, you should know about colligative properties. In this video, we will discuss colligative property. There are many number of properties of solutions which depends on the number of solute particles irrespective of their nature relative to the total number of particles present in the solution. These include relative lowering of vapor pressure of the solvent, depression of freezing point of the solvent, elevation of boiling point of the solvent, and osmotic pressure of the solution. These properties are called colligative properties. We will discuss each in detail, and in this video, we will deal with the relative lowering of vapor pressure of the solvent. As mentioned previously, after the addition of non-volatile solute to a solvent, the vapor pressure of the solvent in the solution would be less than that of the pure solvent. Here, you can recall the Rolle's law. By Rolle's law, you may write P1 equal to X1 P1 0, where P1 0 is the vapor pressure of the pure solvent. P1 is the vapor pressure of the solvent in solution and X1 is the mole fraction of the solvent. Now, the lowering in vapor pressure of the solvent, delta P1 can be represented as the difference between the vapor pressure of the pure solvent P1 0 and that of the solvent P1 in the solution. Substituting for P1 from equation 1, you may rewrite delta P1 equal to P1 0 minus X1 P1 0. Next, rearrange this equation. You may write delta P1 equal to P1 0 into 1 minus X1. Knowing that for a binary solution, the total mole fraction X1 plus X2 equal to 1, the equation reduces to the form delta P1 equal to X2 into P1 0, where X2 is the mole fraction of the solute. Now, we will define the term relative lowering of vapor pressure. The lowering of vapor pressure relative to the vapor pressure of the pure solvent is known as relative lowering of vapor pressure. That is delta P1 by P1 0. Comparing with equation 2, you may write delta P1 by P1 0 is equal to P1 0 minus P1 divided by P1 0. Besides rearranging equation number 3, you may also write the relative lowering of vapor pressure delta P1 by P1 0 equal to X2, the mole fraction of the solute. This indicates that the relative lowering of vapor pressure depends solely on the mole fraction of the solute, independent of its nature. Further, if N1 and N2 are the number of moles of solvent and solute respectively, then you may write the relative lowering of vapor pressure as P1 0 minus P1 divided by P1 0 is equal to N2 divided by N1 plus N2. For dilute solutions, N2 is very less than N1. Hence, neglecting N2 in the denominator, we have P1 0 minus P1 divided by P1 0 is equal to N2 divided by N1. Next, we will discuss the expression to calculate the molecular mass of solute. The number of mole can be expressed as the ratio of weight to molecular weight. Thus, representing N1 and N2 in terms of weight and molecular mass, you may write N1 is equal to W1 divided by M1 and N2 equal to W2 divided by M2. Substituting this data in equation number 4, you may write the relative lowering of vapor pressure P1 0 minus P1 divided by P1 0 is equal to W2 divided by M2 into M1 divided by W1, where W1 and W2 are masses and M1 and M2 are the molar masses of solvent and solute respectively. This equation shows that knowing all the other quantities, the molar mass of solute, that is M2, can be calculated. You just need to rearrange the equation. Now, let us try to solve the question which I have asked you during the beginning of this video. Here, the solute is sweetener and the solvent is water. The given information is weight of solute W2, which is equal to 18 grams, molecular weight of the solvent, which is water, is equal to 18 grams per mole, and weight of the solvent is given as 100 gram. Vapor pressure of pure solvent is 17 millimeter of mercury, and the reduced vapor pressure P10 minus P1 is equal to 0.30 millimeter of mercury. You need to calculate M2, the molecular weight of the solute. By rearranging equation of relative lowering of vapor pressure, we can get the expression to calculate the molecular weight of the solute M2. Substituting the values in the equation, you will get the molar mass as 183 gram. This molecular weight corresponds to that of saccharin and not sucralose. Thus, based on the data of relative lowering of vapor pressure, you may calculate the molar mass of added solute. Here is yet another question for you. Tell me the purpose of adding antifreeze to the car radiator. In general, antifreeze offers dual use, boil over protection and freeze up protection of the water in car radiator. How does antifreeze perform in these functions? One can explain the chemistry of antifreeze based on two colligative properties, elevation in boiling point and depression in freezing point. We will discuss these in our next video. Now, let me summarize the topic.
Manorama Horizon. Learning made simple.